All right, we're gonna finish out our examples that are on that second page. So we learned that the sum of the exterior angles of any n-sided polygon, so any polygon of any size, is 360 degrees. So it doesn't matter what n is, no matter how many sides there are to the polygon, that's going to be what the exterior angles add up to. And just remember that an exterior angle, like if I have let's have a pentagon, an exterior angle is if you continue one of the sides beyond the shape, like that's an exterior angle. So all of these exterior angles would add up to 360 degrees. Oops, that last one looks a little funny. So then the measure of a single exterior angle for a regular, so again, it has to be regular because, like, for example, in this pentagon that I just drew over here, some of these angles are definitely smaller or larger than others. So in a regular or equilateral polygon, the measure of one exterior angle is just 360 degrees divided by the number of angles. So for example, if we use, again, a shape that I think we're pretty familiar with, the equilateral triangle, I know for the equilateral triangle, if I do 360 divided by 3, that's what, 120? Well, we already know that in an equilateral triangle that the sum of the interior angles is 180 and that each individual interior angle is 60 degrees. So the interior and exterior angles always make a linear pair. So this 120 right here is the supplement to 60. So no matter what shape it is, interior and exterior angles are always a linear pair. So that's just kind of a way to verify that property. All right, so what's the sum of the interior angle measure? Oh, you know what? These were supposed to say exterior, I think. Is this a typo? Yeah, it is a typo. I'll fix that on the uploaded copy. But what's the sum of the exterior angle measures of a heptagon? So again, for a heptagon, we said that n equals 7, so it has 7 sides. But again, it doesn't matter how many sides because the sum of the exterior angles is 360 no matter what. All right, and this other one should also be exterior. I'll fix it on yours. All right, what's the measure of one exterior angle of a regular 14gon? So again, we'll just use that formula that's right above. We'll take the 360 degrees and divide that by 14, because not only is 14 the number of sides and interior angles, that's the number of exterior angles the shape's going to have as well. So 360 divided by 14 is approximately 25.714. So again, it's okay to get decimals, and sometimes you won't, sometimes you will. All right, let's try these last two examples. They're not really specific to exterior angles, it just kind of brings it all together. So if the measure of one exterior angle of a regular polygon is 36 degrees, how many sides does the polygon have? So it matters that we're talking exterior angles, and we're talking about a regular polygon. So again, our formula for that is that, like, 360 divided by n equals the measure of the exterior angle. I'm just going to write that out in words. Measure exterior angle. All right, so what we have is 360 degrees divided by n sides and angles equals, well, this is the measure we're given, 36 degrees. So you could probably do this one without actually having to do the math, but algebraically, if we want to get rid of the division of n, we can multiply both sides of our equation by n. So on this side, the division and multiplication. Those are inverse operations, they undo each other. We now have 360 equals 36n. And so if we divide each side by 36, we'll get that 10 equals n. So the polygon has 10 sides, and therefore we could call that a decagon. All right, in number 2, we're asked to find the measure, if the measure of one interior angle of a regular polygon is 157.5 degrees, how many sides does the polygon have? So this is really similar to the question above, but the difference is we're now talking about interior angles. So we know the formula for the measure of a single interior angle in a regular polygon is the sum of the interior angles divided by the number of angles. And that gives us, whoops, oh my goodness, what did I just do? Sorry, my pen's going crazy. My computer pen. Come on, pen. All right, that gives us the measure, oh my goodness, the measure of one interior angle. All right, so we know that 180 times n minus 2 over n equals 157.5. So if we want to solve this algebraically, kind of like how we started that last problem, we could multiply both sides by n. And by doing that, that would undo the division of n on the left. So our new line, scoot this up a little, our new line would read 180 times n minus 2 equals 157.5 times n. All right, from there, the next thing we could do is we could use the distributive property to distribute the multiplication of 180 to both terms in that binomial. So 180 times n is just 180n. And then 180 times negative 2 is negative 360, so minus 360. The right side stays the same. All right, then if we want to collect all of our variable terms on one side, we could subtract 180n from both sides. And then make sure you enter that subtraction in the right order. So 157.5 minus 180 is negative 22.5. And remember, this 360 on the left is still negative because it obviously won't make sense if we get a negative value for n. We can't have a negative number of sides. All right, so negative 360 equals negative 22.5n. And then lastly, if we want to solve for n, just divide both sides by negative 22.5. All right, negative 360 divided by negative 22.5. I know a negative divided by negative is a positive, and that comes out to 16. So 16 is the value of n. And for our purposes, we just call that a 16gon. It's possible that it has a special name that I don't know about, but you don't need to know about it either. All right, that's it for this one.